Before watching this video, you should have a good understanding of how to draw Lewis structures with single and multiple bonds. In this video, we will be drawing Lewis structures of polyatomic ions. Remember, polyatomic ions are covalently bonded molecules that have a charge. Let's first look at the problem with H3O. We're going to follow the rules to draw H3O. We have 3 hydrogens, and each hydrogen brings 1 valence electron to this molecule. So we have a total of 3 valence electrons just from the hydrogen. We also have 1 oxygen represented, and each oxygen has 6 valence electrons. So total from the oxygen we have 6 valence electrons. Now if we add up the total number of valence electrons for the whole molecule, we get 9 valence electrons. The next step in drawing H3O is to draw the skeleton structure. Now remember, hydrogen likes to be on the outside, so we will put oxygen in the center surrounded by 3 hydrogens. Now the next thing that I want to do is connect my oxygens and hydrogens using bond lines. Now remember, a bond line represents 2 shared electrons. Finally, I complete my octet on the oxygen by adding 2 electrons, or 1 lone pair, to that oxygen atom in the molecule. Now if I count up my number of electrons, I get 8 electrons, but I should be representing 9 electrons. So what do I need to do? Well, I'm going to add an electron to this molecule. I'm just going to add it to the oxygen. It's not going to make any sense, but it needs to be there the way that this is represented here, the way that this is written. It needs to be there. So I'm going to add that extra electron to oxygen, and even though my 9 electron count is satisfied, this is a very unstable molecule. H3O, as it's written, is an unstable molecule. So what do I need to do to make it stable? Lewis structures and Lewis theory allow us to answer this question and to draw a stable molecule of H3O and show what we need to do to H3O to make it stable. So I'm going to draw my skeleton structure here. We have oxygen in the center surrounded by 3 hydrogens, and draw my bond lines in between the oxygens and the hydrogens so I have this molecule. And then make sure that my octets have been satisfied. My oxygen has its octet. It's surrounded by 8 electrons. Now this is a stable molecule. So what's the difference between the unstable and the stable? Well, there's 1 less electron in the stable molecule. Now you know that when an atom loses an electron, it gets a positive charge. When a molecule has 1 less electron, it also has a positive charge. So we need to put a little plus sign around this polyatomic molecule, which is now an ion called a polyatomic ion. So in my first structure, I have H3O, which is an unstable molecule with 9 valence electrons that have to be represented, and that's kind of what makes it unstable. My second structure is H3O+, which has 8 valence electrons that need to be represented. Now this is a stable ion. Now because it's a molecule and an ion, we call it a polyatomic ion, which is an ion that has covalently bonded atoms that make it up. Now, when we represent covalently bonded ions, we put brackets around the covalently bonded portion and put the charge on the outside of the brackets. This is just standard notation for writing, drawing Lewis structures of polyatomic ions. Now let's practice by drawing these polyatomic ions. So we're given ammonium here, which is NH4+. We're going to follow all of the same rules with 1 tiny exception. So follow along with me. We have 1 nitrogen, and each nitrogen has 5 valence electrons. So 1 times 5 is 5. The total number of valence electrons from the nitrogen is 5. And we have 4 hydrogens. So 4 hydrogens in this ammonium ion, and each hydrogen brings 1 valence electron that it can use in covalent bonding. So the total number of valence electrons from the hydrogens is 4 valence electrons. Now if we add them all up, we get 9 valence electrons that need to be represented. But let's deal with the fact that this particle has a charge. So in order to get that positive charge, it had to have lost 1 electron. So rather than having to represent 9 valence electrons, we only have to represent 8 valence electrons, which will make life easier for us later on. So let's write out or draw the skeleton structure. Remember, hydrogen likes to be on the outside, so we'll put nitrogen in the center and we'll surround it by 4 hydrogens. So we're drawing out the skeleton structure. The next thing I want to do is add my bond lines. So we're going to add bond lines between the nitrogen and the hydrogens. So what we're doing here is we're just adding lines to represent shared pairs of electrons. Now, nitrogen is satisfied with the octet rule and the hydrogens are satisfied as well. So they have complete outer shell. So everything here in this molecule has a complete outer shell, and we've only represented 8 valence electrons, which is what we want to represent. This whole ion has a positive 1 charge, so I need to put it in brackets and represent that with a positive charge. Why don't you pause the video and try to draw hydroxide on your own? So when we draw hydroxide, we start out with the number of valence electrons contributed by the oxygen, which is 6, and we have 1 hydrogen in this molecule, in this polyatomic ion. So this hydrogen will bring 1 valence electron to the table, giving us a total of 7 valence electrons. But dealing with that charge there, in order for something to have a negative charge, it has to have gained an electron. So we're going to show this representing 8 valence electrons and not 7 like originally calculated. So we have our skeleton structure now that I'm drawing. We have the oxygen and the hydrogen, and we're going to connect the oxygen and the hydrogen using a bond line to 2 shared electrons, and then we're going to complete the octets. So we have oxygen needs extra electrons around it to complete the octet, and hydrogen is satisfied. It has a full outer shell with 2 electrons. So if we count up the number of electrons represented, we get 8 valence electrons, which is the number that we started with, so that's good. And then we will finish this molecule drawing, or this ion drawing, by adding brackets around the portion that is an ion and then putting the charge on the outside of the brackets. So this is how you draw polyatomic ions. Everything is the same except when you add up the number of valence electrons that need to be represented in your structure, you have to take into account the fact that it has a charge. So if it has a positive charge, you're going to subtract electrons, and if it has a negative charge, you're going to add electrons. This is the same thing that we did when we were dealing with ions before. So it's not new, except now we're dealing with molecules losing and gaining electrons and not just atoms losing and gaining electrons.